Welcome back, focused learners. You are tuned in to another deep dive on the Explainer. Today, we're embarking on a truly fascinating exploration. We are pulling back the curtain on the crypto asset market to examine the hidden mathematics and the actual physical infrastructure that drives these networks, all based on some really intriguing recent research. We're getting past the hype today, and we're focusing purely on the mechanics.
So let me ask you this. Is the crypto asset market just a chaotic bubble, or is it actually a predictable physical system? Now, most of us are used to the standard narrative, right? That crypto is just this volatile, chaotic digital gold rush driven entirely by speculation. But what if we challenge that for a second? What if, beneath all those seemingly random bubbles and wild crashes, there's a deeper mathematical reality at play? A predictable physical system governing how these markets actually grow?
Here is our roadmap for how we're going to unpack this today, based on the source material. 1. The illusion of digital gold. 2. Understanding the power law. 3. Institutional noise and collapse. 4. The infrastructure of BSV. And 5. SPV and global scale.
Let's jump right into Section 1, the illusion of digital gold, the speculative disconnect. Okay, this number is incredibly important. 7. Just 7. This represents the average maximum transactions per second that Bitcoin Core, or BTC, can process today. Why is it so low? Well, the source points out that the protocol choice of an artificial 1 megabyte block limit acts as a massive choke point. It's essentially strangling the network's capacity. And as this quote from our source material highlights, this artificial throttling causes a profound dissociation. You see, the original design was for a peer-to-peer electronic cash system, but the analysis suggests that by limiting the block size, you fundamentally break the intended economic incentives. The actual utility of the network plummets, and it shifts almost entirely to this speculative digital gold narrative, which effectively removes its commercial viability as a payment rail.
Section 2. Understanding the power law, the mathematics of network growth. Let's look at the actual math.
If utility gets sidelined for speculation, what actually drives long-term value? Well, this brings us to physicist Giovanni Santostasi's Bitcoin power law theory, combined with Metcalfe's law. It suggests that a network's value grows proportionally to the square of its active users. Think about network growth like the spread of a virus, or even the expansion of a growing city. It's an iterative process, you know? It's a feedback loop where the output continuously feeds back into the system to fuel even more growth. It actually behaves like a highly predictable physical system.
And the source material emphasizes a really foundational theme here. You literally cannot understand the game of life in networks without the power law. For this natural mathematical growth to happen, the paper argues a network absolutely demands frictionless flow. It needs an unbounded physical substrate to expand upon. Because if it doesn't have that, the iterative process of growth just hits a brick wall.
The sheer consistency the research reveals here is honestly remarkable. Despite all the wild market bubbles we hear about on the news, the system exhibits 15 years of scale invariance. That means its growth patterns look identical whether you zoom in on a single month or zoom out across a whole decade. Modeled on an exponent of 3, the math projects a $1 million benchmark within 10 years. Now, it's important to note, this model strictly excludes short-term volatility and black swan events. It focuses purely on a long-term scale invariant trajectory.
Moving on to Section 3, institutional noise and collapse, the cost of mutability.
So, if the math is so incredibly predictable, what actually disrupts it? The researchers contrast two very distinct approaches here. A mutable, changing protocol introduces what they call institutional noise. When the rules constantly shift, it creates a hypergame. Everyone's just trying to outmaneuver the changing rules, which pushes miners and operators completely away from long-term infrastructure investments. Instead, they go straight for short-term rent-seeking and speculative extraction. Conversely, a locked, immutable protocol provides the stability you need for predictable economics, cooperative strategies, and real long-term capital investment.
The source argues this loss of stability has serious, real-world consequences. We get broken technology dealing with massive network congestion. We see broken operators, think FTX or Terra/Luna, characterized by insolvency and wildly disorganized management. Ultimately, constantly changing the rules leads to misallocated capital. It perfectly mirrors the exact failures we see in fiat monetary decay, just playing out right inside the crypto space.
Section 4. The infrastructure of BSV, solving the physical substrate.
So how do we fix this? Let's shift away from the problem of institutional noise and look at the technological resolution explored in the source material Bitcoin SV.
Remember that 1 megabyte limit we discussed earlier? While BTC is still capped at 1 megabyte and Bitcoin Cash sits at 32 megabytes, the paper highlights how BSV tests unbounded block sizes. We're talking 4,000 megabytes, that's 4 gigabytes, and well beyond. According to the research, this massive, unbounded capacity acts as the essential physical substrate that allows the power law we talked about to actually operate without friction.
Because of that unbounded size, the source notes BSV is achieving absolutely staggering scale. 1 million. That is the number of transactions per second achieved on BSV's Terranode infrastructure using AWS. The argument here is that this kind of throughput fundamentally transforms the network into a globally scalable enterprise utility. This structural divergence creates completely different ecosystems. Restricted networks feature high, totally unpredictable fees and super low volume, running on consumer-grade nodes just to support a speculative store of value. Meanwhile, unbounded networks feature incredibly stable, sub-cent fees with massive volume, running on industrial enterprise server clusters. The analysis suggests that this setup is what creates genuine macroeconomic stability. It makes the network highly viable for real-world utility, things like stablecoins and institutional settlement rails.
Section 5. SPV and global scale, the key to true decentralization.
But you might be wondering, if it's a massive industrial network, how do everyday people interact with it securely? This brings us to Simplified Payment Verification, or SPV, which the research points to as the absolute key to scaling without losing decentralization. An SPV client only needs to retrieve a tiny 80-byte block header. Then it queries miners for a specific Merkle proof, which is essentially just a cryptographic receipt. Finally, it mathematically verifies that a transaction is included in the block. It achieves total financial sovereignty without requiring the user to download a multi-terabyte blockchain.
Now, what's really interesting about this is the sheer mathematical efficiency of the design. Thanks to logarithmic efficiency, which basically means the effort required barely increases even as the data grows massively, a block containing 100,000 transactions requires fewer than 20 hashes to verify. 20. According to the source, this makes global scaling instantly viable for anyone, anywhere in the world.
To sum up SPV, it drastically reduces computational overhead while entirely maintaining the cryptographic guarantees of proof of work. And by using cross-peer verification, it mitigates network partition risks. The researchers really emphasize that this isn't some new workaround. It is a foundational design straight from the original white paper that makes true decentralization practical for the things you use every single day: your smartphone, the Internet of Things, and instant micropayments. Which leads us to this incredibly powerful conclusion from the source material. A fixed, stable rule set isn't just about technocratic nostalgia. It is an absolute economic requirement. Without a stable base layer, you simply cannot build equitable, scalable institutions. You just get institutional noise and eventually the collapse of capital.
And that brings us right back to our core theme one final time. To truly understand these digital assets, the research suggests you have to look past the market hype, past the bubbles, and view them through the lens of physics, network topology, and immutable mathematical laws.
I'll leave you with this final thought. If the mathematical laws of network growth absolutely demand frictionless, unbounded scale, ask yourself, is the digital infrastructure you are currently looking at built on a stable, physical foundation, or is it just a mutable house of cards? Thank you to all our focused learners for joining me on this explainer. I really hope this structured dive has given you a completely new perspective on the macroeconomic reality of crypto assets. Keep learning, and I will see you next time.